How does state really work in React.js? Well, in today's video, you're going to learn just that. You're going to learn about the useState hook and what state is, and we're going to show some examples along the way. So I'm going to link this kind of starter project in the description below. If you want to follow along, you can just use git clone to clone this repo and then run npm install in your code editor of choice, and you can follow along here. But to start here, state is a component memory. It represents the current data on a dynamic page. So what does that actually mean? What does that actually look like? Well, we'll of course show what it looks like, but I think it also helps to show what this doesn't look like. So for example, we have this counter button here that shows the current count. And I'm going to open up our console, go to console, I'm going to clear it. And if we go to VS Code here within this project, you're going to see I have this component or this function called React State. I set a global variable, let count is equal to 0. And then this is where I render how does state really work in React. And then our count button with the current count. And that displays our count variable right here. And when we click on this button, we call this handle increment function on this on click, which is this function right here. It should increment the count. So plus equals 1. So increments the count by 1. And then also in the console, it's going to console.log the current count. What you would expect is if we click on this button, it's going to increment the count, and then it's going to show the current count right here on the page. So let's go ahead and see if this works. So I'm going to click on this. You can see it doesn't change what we see on the page, but the values in the console are actually showing the incremented number. So we see all these numbers going up, but it's not showing on the page. So what's going on here? Well, this component, it's not getting its memory updated. It's not being representative of the current value in this dynamic page. By dynamic, I mean that the user can interact with this page and the values of this page can change. So if the data on a page can change and those changes can occur over time, then this is a dynamic page and it's going to need to use some sort of memory for this component. So it remembers what the current data of the page is. Because if it has no way of remembering the current data of this page, it's not going to be able to show the user the correct page that it should see for the current UI. And this memory is state. So the state of our web page right here is a count of 0. But how can we make sure that the state updates and actually shows what our current count should be? Well, a lot of people would say you should just, use a JavaScript variable and update that variable. Well, we can see here that this doesn't work. React doesn't work that way because in React, you need to use something called a hook that allows you to, when you update a variable, it actually re-renders this part of the web page and it shows the updated variable. So the way that we can actually do this in React and we can add state to this component is we need to use the useState hook from React. So to do this, I'm going to get rid of, we'll keep handle increment for now, but in the body of this function, we're going to say const state is equal to useState. And we are going to import that from React. So import useState from React, and we're going to call this function. Now, there's a couple of things that you should know about useState. For one, you can only call a React hook, which is useState. And generally, a hook is a function that React is going to give you from its library. It's going to be a function that you get out of the box in React, and you can import that into your components. But it's going to be a function that allows you to hook into React features. And these features of React are going to be things like state and using effects and using references to variables. And we'll cover this stuff as we go. But hooks are just functions that you get from the React library. They're functions that you get out of the box that you can use within your application to allow you to hook into React features. So we're using this useState hook, and it's just a function from React that is going to allow us to use the feature of React called state, which state, it's going to allow us to have components have some sort of data over time or some memory of data. So we can have this changing data over time. And this could be for account, it could be for text inputs, it could be a whole bunch of stuff. And we'll show you a to-do list later on just to show you another example. But we call this useState hook. But what we need to remember is that when we call the useState hook, we're going to call it with an initial default value. So we're going to initialize our count to 0. So we're going to initialize useState with 0. So we're going to call it with that value. And now let's just console.log our state to see what that looks like, to see what useState returns. And if we see state right here, and I open this up, you see it returns an array to where the first value of this array is 0, which is the value that we initialized useState with, or we called useState with. And then the second value is a function. So what useState returns here is an array of 2 values. The first value is going to be your current state, which we initialized it to 0. And then the second value is going to be a function to update your current state. And what you will commonly see this written as is instead of just saying like const state is equal to useState, you will see people automatically destructure the first and second values from useState. So it will actually look more like this. I will destructure using square brackets the current value, which I'm going to call count, and then the second value I'm going to call set count. So useState returns an array of 2 values, the current state and a way to set the state or update the state. And we are automatically destructuring those values using JavaScript destructuring syntax to get to the current count and a way to set the count. And I'm going to remove this counter here. And I'm also going to remove this console.log statement. So now we have our count and set count functions, but instead of just setting our count like this, we now want to use our set count function. So I'm going to say set count. Well, how should I do this here? Should I just say it's count plus 1? Well, a better way to do this is when you are using the state setter function from useState, you can either call that state setter function with just like an absolute value. So I could set the count to 4, or I could set the count to 10, and that's going to update the state to whatever value I pass in here. But sometimes you want to set the state based off the previous state. And anytime you want to do that, it's actually best to pass a function to your state setter function. So here, I'm going to pass an anonymous function, and it's going to give us the previous count as an argument automatically. And then I'm going to set the current count to the previous count plus 1. So what we're doing here is we are passing a function to this setter function return from useState. We're passing a function into it, and React is automatically going to pass our previous count to that function. And then we want to just return our updated state based on our previous state. And in this case, we want our updated state to be our previous state, our previous count, plus 1. And now, if I click this button here, you see we are getting our updated state. And I'm going to clear my console, and then you can see our console now matches what we're seeing here. And the reason this works is because when you use this state setter function, that is automatically going to tell React that it needs to re-render this part of the page. because you set a new piece of state, so you need to re-render this component. So anytime you set state in React, it is going to re-render this component, which is going to give the updated value to the page, which is now going to allow this component to show this updated data over time, or to kind of remember the current data of the application or the current state of this page. One thing that's important to understand about state and components in general is that each component is going to have its own independent private state. So the way I'm going to show you this is we're going to create a new file, and it's just going to be called count component.jsx. And technically speaking, we are working within a Next.js application, but to make this just be React, just put use client at the top of the page. It's going to just make this a React component here, but that's a Next.js specific thing. What I'll do is I'm going to say export default function count component. And then what we're going to do is we're going to take this button right here, and we are going to return that in this component. We're going to return this button. And then we're also going to take this logic right here. We're going to copy it, and we are going to paste it here, and make sure that you import state from React, or import useState from React. And then I'm going to remove this console log here because we don't need it anymore. But now we've created our own count component. So within this page, we can remove all this logic here. And instead of hard coding this button, we can just render our count component. And if I didn't mess anything up, we should see that we have the same exact user experience here to where we see this. However, like I was saying earlier, each component has its own independent private state. So if I render another count component here on this page, what you're going to see is now I have one counter that has the count of 9 and another counter with a count of 0. And I can increment these independently of each other. So they have their own private state here, because in React, this component is going to have its own private state, and so is this component. So each component can separately remember their current data or their current values. So just keep in mind that each component is going to have its own private state. Even if you render the same component twice on the page, those components don't really know of each other. And when I update the state in this count component, that is the only thing that's going to re-render on this page, is this component is going to re-render. But then if I update this count component, that component is going to re-render. And they don't really know of each other on this page. Those are the only sections of this page that are now going to be re-rendering. So each component is going to have its own private state, even if you render the same component twice on the page. So now that you kind of know what state is, how the useState hook works, and some other principles of using state in React, a good test for you is if you can now create a to-do list. So basically just a list of text that when you have an input, they can type in the input, they can select add to do, and it is going to add a to do to the page. And for the sake of this, maybe don't worry about deleting to dos. Maybe I'll do that in my example. I'm not sure yet. It's going to be a surprise, but see if you can build that. But I'm going to move on and build that right now. So if we want to add to dos on this page, well, what I can do is we can create our own to-do component. So what I'm going to do here is do a new file, and I'm going to say to-do component.jsx. We're going to say it's a use client. Just put that at the top of your files for now, just to make sure everything is just basic React here, client-side React. But I'm going to say export default function to-do component. And what are we going to need here? Well, we're going to need a to-do list that we're going to update. So this page, it's going to have an input to add a to-do, and then a to-do list. So we're going to need const to-do list, comma, set to-do list is equal to useState, and we're going to initialize it as an array. And that's an important thing as well. You can initialize useState with numbers, strings, arrays, objects, really whatever you want is what you can initialize it with. So we're going to initialize our to-do list as just an empty array. And then we have our set to-do list function. Now, we're also going to want, and let me also import useState from React. What we're also going to want is we're going to want to have an input on this page that the user can type into and add a to-do. So we're going to say const to-do input and set to-do input is equal to useState. And I'm not really going to worry about styling at all right now. We're just going to render an ugly component onto our page. And I think that's going to be just fine. But what should we initialize this as? Well, I think it's going to be best to initialize it as a string. So we're going to initialize our to-do input as a string. And now we need to return. Well, what do we need to return? I'm just going to return a wrapper div, but then in this div, I'm going to render an input that is going to be of type text. And we are going to say that the value is equal to our to-do input. And then for the on change of this input, we're going to pass an inline function in which we're going to set the to-do input. We're going to accept the event here, and we're going to set the to-do input to be the event.target.value. And I think that's all we're going to need for that. But then we're going to have a button here that's going to say add to do. When we do an on click for this button, what we're going to want to do is I'm going to pass an inline function as well. You could, of course, put these in their own functions up top here, and maybe that would actually look better in this case. But what we want to do is we want to set the to-do list with our new to-do. But we want our to-do list to be our previous to-do, so we're passing in a function to our set to-do list. And we want to make sure we return an array where we spread our previous to-dos, but we add our new to-do. Our new to-do is just going to be our value of our to-do input. So we have our input that is going to set our to-do input to be our event.target.value. And then we have our button that is going to set our to-do list when we click the add to-do button, and it's going to set it to be our previous to-dos, and it's going to return an array with our previous to-dos, but then it's going to have our new to-do in here as well. I'm going to open up curly braces, and we're going to take our to-do list. We're going to map over it, accept a to-do, and then we are going to return, I don't know, maybe I'll just return, I should return LIs here, so I guess I'll do that. And we'll render our to-do list within an unordered list here. And I'll move this up. I thought about just doing it with an array of like spans or something, which would also be fine, but probably not the right thing to do. And we'll just render the to-do within an LI. And then we'll just set the key. We don't have an ID. We might add one in a second, but we'll just set the key to be a to-do right now. I think this might work. Let's go check. Let's remove one of our count components, and I'm going to now render my to-do list or my to-do component within our home page, which is called React State here. And if we come back, I'm going to close my console. We see our beautifully styled input, and I'm going to type in something to do, but I don't see anything because I think my text is white and my input is white. So let's actually add some styles here. So to do component input, I'm going to just do style, and I'm going to set color is black, right? Yeah, that'll fix it. Okay. Something to do. And I'm going to click add to do, and hey, we added a to do. Now, one thing that we could do here is after we add it to do, we could also clear our text input. So for add to do here, I might I'm going to actually create a function called handle add to do. And we are going to take this logic where we're going to set our new to-do list like so. So set to-do list to be previous to-dos, return an array of all of our previous to-dos plus our new to-do. But then we're also going to set our to-do input to just be an empty input. So we're going to clear our input, and then on add to do, we'll just call this function instead. So now if I add another to do, you see it adds the to do here as well, but it clears the input, which is probably what we want here. And you can also see that our count button still works independently of our to-do list because our two components have two separate pieces of state, something to do 3, and all this is working well. Now, what if we wanted to delete a to-do? Well, we can do that fairly easily here. And I'll show you this quick. What we can do is when we add a to-do, we probably want our to-dos to have some sort of ID. So we're actually going to make our to-dos an object in which we're going to say our text is equal to our to-do input, but then we're going to set our ID. We're just going to take the easy route and do math.random and make it a little bit hacky right now. You probably wouldn't want to do this in an actual application, but for now it's fine. But each to-do now is going to be an object that has a text and ID property. And then we're going to render our to-do.text. But our key is going to be our to-do.id here. We also want to render, so instead of just rendering a list item, we will render our to-do.text, and then we'll also render a button that just has an X, and then our on click is going to be handle delete to do, but we're going to want to pass our to-do ID. So I'm going to pass an anonymous function that's going to be handle delete to do, and we're going to pass our to-do.id. And then I'm going to create a function called handle delete to do. And then it's going to take an ID. And then what we need to do is we need to set our to-do list to be our previous to-do list without the to-do with this ID. So we want to pass a function here. So we get our previous to-dos. And then we want to return our previous to-dos dot filter. I'm going to accept a to-do, and I'm going to say to-do.id is not equal to our passed in ID. So basically return an array because the filter method on an array returns an array. Return an array where we filter in every to-do that is not equal to the ID that we pass for handle delete to do, which should be the to-do with an X right here. So I think this should work here. I don't know what's going on here. We did to-do.text here, which I need to refresh this because when I initially added my to-dos, I didn't add them with an object here. So I'm going to just refresh this page to clear the state, but I'll say add to-do 1. So we see it now. To-do 2, add to do. And if I click the X, it gets rid of the right to do. Let's just add a few more to-dos just to make sure I'm correct here. And we should be able to add specific to-dos, and we can. And that looks like it's working correctly. So hopefully that example helped. Let's recap what we just went over here today. So state is going to be a component's memory, and it represents the current data of a certain component. And it helps you create dynamic web pages. So the user can click on these values, it can add different things to the page. And then this component right here, it remembers and it updates based on what the kind of user tells it to do, and it shows the current data of the page. Same thing with this count component. And a regular variable isn't going to work. A regular JavaScript variable isn't going to work because you're not telling React to update the page with the current new state or the current new data. So it's best to use the useState function from React, in which This is a hook, which is just a function from React that is going to allow you to hook into React features. In this case, useState is going to allow you to use the state feature of React, in which when you call this function, you call it with the default value that you want your state to be. And this can be a string, a number, an array, an object, a Boolean. And then from there, it's going to return an array of two values. The first is going to be your current state, and the second is going to be a way to update your state. And every time you update your state, it is going to re-render that component so it shows the updated value on the page. So I click my count component, and it's going to re-render this count component with the updated state. And when you call this state setter, you can either call it with just an absolute value like we're doing here, setting the to-do input to be just a string, or you can call it with a function in which React is going to pass as an argument to that function the previous state, and then you can use the previous state to then return the new updated piece of state based on your previous state. And then finally, each component is going to have its own isolated piece of state. So even if you render the same component multiple times on the page, like rendering this count component multiple times on the page, we can use these components independently of each other because each component is going to have its own independent private piece of state. So hopefully this video helps you out with understanding state in React. I know it's kind of a lot, but this is one of the very core concepts of React. In this demo application here, where you can add different tasks, and I know to-do lists or task lists like this are pretty much a cliche at this point when it comes to web development tutorials, but it does kind of get the point across well. So we have this task list, and you can add new tasks, you can delete them, edit them, save them, mark them as checked, so on and so forth. Now, we currently manage this with just using React state. So if we go to the actual component here, what you're going to see is that we have this useState to where we manage our list of tasks. And then we have our like edit task ID, edit task title, new task, so on and so forth. And then throughout this, we have a function to add a task, delete a task, toggle the completion of a task, start editing a task, save editing, and then kind of all of our JSX here to render things out and to call the different event handlers. So that's great and all, but today we're going to kind of convert this to, instead of using just the useState hook in React, we're going to use the useReducer hook and use reducers to manage this state rather than just using useState. Now, towards the end of this video, we're going to cover some like pros and cons of reducers because, you know, they're definitely not the go-to solution for managing state all the time. And, you know, we'll kind of see what it looks like here, as sometimes it actually results in more code, but it can also be more manageable. So there's kind of a little bit of a give and take with reducers, but I'm going to show you how the useReducer hook works and how we could kind of fit it in to this task manager component. So first of all, I probably don't need this side menu open, and we can kind of clear up those files up top. But what we're going to do first here is we are going to skeleton out our useReducer call. So instead of having our useState call here, what we're going to say is, and this is going to, of course, throw errors here at first because we're going to have duplicate pieces state. But we're going to say const tasks, comma, dispatch is equal to useReducer. So this is a hook from React, very similar to useState. It's just another hook that helps you manage state. But what it's going to accept as arguments here is, first, it's going to be a reducer function. So in our case, we're going to call it task reducer. And what a reducer function does is it effectively takes multiple things and then reduces it down to one thing. So in our case, it's going to take the current state as well as some sort of action that the user takes. And we're going to display that or represent that action as just an object. So it's going to take the current state and an object, and it's going to reduce that down into what the new state should be. And I'll, of course, create this function and show you more of how it works. But then as a second argument to the reducer function, it is going to take the initial state. So what we can do here is above our task manager component. And if you see this use client here, just ignore it. This is technically a Next.js project, but this is all just pure React code. What we're going to do here above our component is I'm going to say const initial state is equal to, and it's basically going to be what our initial state was right here for useState. And I'm going to pass it like so. And I'm just going to get rid of this useState call here. Now the useReducer hook, it's going to return our current state, and it's also going to return a dispatch function. And all this is a way for us to tell our reducer function effectively what action the user took. So when we call the dispatch function, we might say something like the user added a task. Okay. And then the reducer function is going to accept the current state and that action, and then just figure out how to update the state from there. So let's actually start building out this reducer function. So below my initial state here, I'm going to say const task reducer is equal to, well, what arguments is it going to accept? It's going to accept the current state, and I'm just going to say it's state. And it's also going to accept some sort of user action. So action. And then we're going to make this an arrow function. And now once in this function, what we basically need to do is, okay, we need to see if the action was that they added a task, then we need to update the state based on that action. If the action was they deleted a task, we need to update the state based on that action. So a very common way to do this is using a switch statement, because we're going to have different cases of different actions the user took. Now you can also write this using if statements, and that sometimes that can be the better approach. But for me, I tend to like using the switch statement because, as you'll see, you can kind of more easily see the different cases for that switch statement. So we're going to say switch, and then this is going to be on the action, and we're going to pass a type property on the action. So action.type, what type of action is it? And this is kind of the convention when using reducer functions. And we'll open up curly brackets, and then I'll do case. And then what should our first case be? What should be an action that we handle here? Well, we should handle whether the user added a task. And one kind of small note is that I am kind of thinking in more so past tense here. So like added a task rather than add task. I've seen it either way, but for me, it just kind of makes more sense like handling an action that the user took. So added a task, deleted a task. So kind of making things past tense to me makes a little bit more sense. And I would say probably is what you're going to see a little bit more often. So for our case, we want to do added a task. And in our dispatch function, we are going to dispatch an object to where the type is added task. So to prevent us from repeating ourselves here, what we're going to do is we're going to create a constant, and I don't know, maybe I'll just say const task reducer, and that's going to be an object where added task is going to be added task. And then I'm going to also do deleted task, toggled task, and edited task. So we have our constants set up here. So now the first case is going to be, we'll do task reducer dot added task. So what do we want to do if they added a task? Well, we're going to return an array where we're going to spread in the previous state. Then we're going to add a new piece of state where the ID we'll just be a little hacky with it and just do date.now. But you're probably going to want to use like some sort of, helper function to generate a ID. The title is going to be, well, on our action object, we also want to pass basically the title of the new task. And the convention here is to pass it on the payload. So for this, the title is going to be our action.payload. So when we dispatch this action, we're going to want to make sure that for an added task, we want to, on the action.payload, pass the new name of the task. And then completed is going to be false for an added task. And really, that should be it for adding a task. But now we just need to go through the other cases here. So another case is going to be taskReducer dot deleted task. And then in this case, we need to return our state dot filter. We're going to accept a task. And we're going to say the task.id is not equal to the action.payload. So when we dispatch an action for a deleted task, the payload should include the ID of the task that we want to delete. And then here we just filter that out. And real quick, whatever you return from the reducer, that is going to be your new state. So we're returning for our added task, our new state plus this task here. For the case of a deleted task, our new state is going to be filtering out the action.payload task, the one we want to delete from our current tasks. So whatever you return from your task reducer is going to end up being your current state. Now we need to do our toggle task, where we're going to return our state dot map, accept our task, and then say task.id is equal to action.payload. If that's true, then spread that task, but say completed is going to be equal to task.completed, but we need to make sure to toggle it. So we'll say not task.completed, else just return the task. So map over our tasks, find the one that matches our action.payload, toggle the completed, else just return the task in our map function. And then the final case here is going to be our taskReducer dot edited task, or we're going to return state.map task, find the task.id is equal to the action.payload. If that's true, spread the task, but then set the title to be the action.payload. Title actually is what we're going to want to do. And this should be action.payload.id, else just have it be the task. So in this case, our payload for an edited task is actually going to be an object that is going to have our action.type on it, but it's also going to have an action.payload, which is also an object that has an ID of the task that we want to edit or that the user edited. And then also the payload is going to have a title, which should be the new title for the edited task. And I will fix these case statements here as well. So let's make sure that they're all kind of lined up with each other and a little easier to read. I would definitely recommend using Prettier, but I do not have that set up right now. But by default in our case statement, we will actually throw a new error and just say unknown action type. And you might also like console log or log out the action or the state right now as well. But we'll just kind of throw this generic error. So that kind of sets up our task reducer, which we're already passing into our task manager here. And then really from here, all we need to do is update our functions to dispatch actions instead of like manually updating the state. So for add task here, we'll keep our check If the new task is empty, just don't do anything. And we'll also keep our set new task title, kind of resetting the state here. But for kind of this in between here, all we need to do is call our dispatch function with an object to where the type is taskReducer.added task. And then the payload, that should be our new task title. So that kind of, to some degree, simplifies our add task function, and kind of a lot of the logic for managing our state is now just in this one single reducer. Since I used a switch statement, you can easily see the different cases here. If you're like debugging, okay, deleted task isn't working, it's very easy to come and find deleted task here. So that should be add task for delete task instead of this logic kind of directly here. We're again just going to dispatch, call that function with an object to where the type is going to be our task reducer dot deleted task. And I definitely could have named that constants object a little bit better. But then the payload is just going to be the ID that we pass into deleted task. For our toggle task completion, instead of setting the state directly, we are also just going to dispatch an action object that has type taskReducer.toggle task. The payload is going to be the ID once again. For start editing, that's going to remain the same because we're still using set state. So you definitely can use useReducer with useState calls. That's perfectly fine to do. But then the save edit is going to be a little bit different, where instead of setting tasks directly, we're going to dispatch our action to where the type is going to be taskReducer.edited task. And then this one, our payload's a little bit more complex. So we'll have a payload that is going to be an object to where the ID is going to be our edited task ID or edit task ID. And then the title is going to be our edit task title. And then everything within our code should remain the same because we're still calling all these functions with the same stuff. We might have actually wrote a little more code there with adding the reducer and adding these constants, but some would argue that this is a little bit more easy to manage because we're just dispatching actions here from these functions rather than immediately updating the state. So a lot of our state logic is just in this one single function that might be a little bit easier to maintain and debug if things aren't working quite correctly. And this is editor Ryan here, but just as a quick note. So I'm not sure if this was clear going through the video and editing it, but when you call the task reducer, your reducer function with dispatch here, so like we dispatch this action, you see that we're not calling it with the current state. And that is because React will automatically pass in the current state to your reducer. So when you dispatch an object or an action, that is effectively immediately passed into the second argument to your reducer function because React will already pass the current state to your reducer. So if that kind of seemed a little bit magic in the video, just know that React automatically passes the current state to it, and then your dispatch function effectively calls your reducer. But since React is already going to pass the current state into it, your action is just going to take that second argument there. So if that was confusing, hopefully that clears it up. So let's go see if this works here. Let's refresh to make sure we're all good. I'm going to add another task, another one here. Let's see if I can toggle them. It looks like I can. Let's edit this one. Let's save. That looks good. Let's delete. So it looks like everything is still working correctly. All we changed was how we manage state under the hood, which is exactly what we want. Let's head to the React docs and just finish on a few things that are important to note. So in their docs here, I'm going to just run through some of their comparison between useState and useReducer, just to kind of give you another overview and kind of their perspective on it. So for code size, generally with useState, like I kind of showed you, sometimes you have to write less code up front, but with useReducer, you have to write both a reducer function and dispatch actions. However, useReducer can help cut down on the code if many event handlers modify state in a similar way. So yeah, it does depend. It is kind of a case-by-case basis, but I would argue that it's not bad to write more code sometimes if it makes things a little cleaner and more manageable, which I think useReducer sometimes does do. But I also think sometimes useReducer does just kind of make things a little bit more complex than it needs to be. Readability. useState is easy to read when the state updates are simple, but when they get more complex, they can bloat your components code and be difficult to scan. In this case, useReducer lets you separate the how of the update logic from the what happened of event handlers. So rather than in our kind of event handler functions right here, rather than focusing on updating the task state directly, we just had to dispatch an action saying, okay, what happened? They added a task, they deleted a task, they toggled a task, and then we let our reducer manage how to actually update that state. So it's kind of separating those concerns there is what they're getting at. And then with debugging, when you have useState, it can be difficult to tell where state was set, but with useReducer, basically everything happens within a reducer. So when we were using useState earlier, we were setting the state here, we were setting the state here, we were setting the state here. Sometimes you'll see it also be done in the event handlers themselves, and we're setting state in all these different places. With useReducer, we're really just setting state in our reducer function. And then for testing, a reducer is a pure function that doesn't depend on your component. This means you can export and test it separately in isolation. While generally it's best to test components in a more realistic environment for complex state update logic, it can be useful to assert that your reducer returns a particular state for a particular initial state and action. So could have some testing benefits. I'm kind of on the fence about this one. I think that you can still find ways to test your components regardless of whether it's using a reducer or useState. Personal preference. Some like it, some don't. That is definitely for sure. For me personally, I'm kind of meh. I tend to default to using useState, but sometimes if it is like a more complex piece of state that is being updated in a bunch of different event handlers, sometimes it is helpful to kind of separate things out into a reducer. But for the most part, useState is my default until things start getting a little bit unmanageable. Then I'll switch over to useReducer. And then for a couple of things for writing reducers well, just make sure your reducer function is pure. And then also each action describes a single user interaction, even if that leads to multiple changes in the data. For example, if a user presses reset on a form with 5 fields managed by a reducer, it makes more sense to dispatch one reset form action rather than 5 separate set field actions. And then I'll of course link these docs in the description below if you want to read more about this. But let's do one last overview of the code here of what's going on, just to make sure that we're all on the same page. So the useReducer hook in React, it's going to accept a reducer function as the first argument. This reducer function is simply going to be a JavaScript function that takes 2 arguments, the current state, as well as an action object that represents some sort of user action that the user takes. From there, within your reducer function, you're going to see what action type it is, what action the user took, and then you're going to return some new state based on the current state and whatever action it was. And in that action, you might also send a payload if you need more information on how to update that state. And that payload might contain the title of a task, the ID of a task, or different things to help you update the state based on whatever action it is. And then whatever you return from your reducer function, that is going to be your new updated piece of state. And then as the second argument to useReducer, it is just your initial state. useReducer is going to return an array of 2 items. The first is going to be your current state, just like the useState hook. But the second is going to be a dispatch function that allows you to dispatch actions for your reducer function. So then throughout your code, instead of just calling the set state function directly, you actually just dispatch using your dispatch function an object that contains basically the information needed for you to update the state in your reducer function. So in add task, we dispatch an object that has a type saying the user added a task, and then the payload of the new task. Same thing with delete task, dispatch an object to where the type is deleted task. The payload is the ID of the task we want to delete. Same thing for toggling a task as well as editing a task. But this time our payload is actually an object with a little bit more information, the title and the ID. So really not too complex. I think sometimes people are a little scared of reducers, but you're really just probably a step more complex than using the useState hook. So hopefully this video kind of helped you see some of the pros and cons of reducers, where they might be useful, and how reducers work in React. So today I'm going to give you the TLDR on how the useEffect hook works in React. So if we go to my application here, for this useEffect hook, in my previous video, we covered kind of when you would use this hook, where it's appropriate, when you shouldn't use it. And the summary of that video is that really you shouldn't be using this useEffect hook here very often. And as you can see, this is just a function that we import from the React library. It's very similar to how you import other hooks from React, like useState, useReducer, useRef, useContext. It is just a function that we import from React that allows us to kind of hook into some React features. Now, as I was saying, you really don't want to use this very often, and it's kind of reserved for situations to where you're kind of stepping out of normal React code. So in my previous video, we kind of covered where there's kind of 3 different types of code in React. You have your rendering code. That's going to be like this block of code right here. All it is rendering JSX. There's not really much else to it. There's no event handlers or setting state or anything like that. But then the second type of code is like event handler code. So like right here, we have this button, and then we have an onClicked where we set some state. Then we have effect code. So, you know, this is kind of an effect, but it's in a user event triggered that effect, because you click the button and then you set some other state elsewhere in your app. It is kind of a side effect, but it's also triggered by a user event. But with effects, it's going to be stuff that you use to where you need to use like a side effect, but it's not triggered by a user event. It is triggered by some other external thing. It could be, you know, you use a useEffect hook to connect to WebSockets, or you connect to third-party APIs, or maybe you have a chat in your application and you're waiting for, well, I guess this is just WebSockets again. You're waiting for that message to come through, or you're waiting on an event, something like that. It's not based on user events, and it's not just your normal rendering code. It's some other effect. That's where you're going to use these. All right, so try not to use these too much, but how they work is that basically you import useEffect from React, just like what I did up here, but it's going to accept 2 arguments. Now, right now, I'm only passing it 1 argument. I'm passing it a function as its first argument here. And that is what your first argument should be, is a function. And by default, when I have a useEffect just like this, it is going to run on every single render of my application. So you can see right now, it's just console logging the current count. If we go back to my app and open the console, you see if I increment my count, it console logs it, which you might think, okay, this is exactly what you might want. However, when you don't pass a second argument to useEffect, like I said, it's going to run on every re-render. So if I set some unrelated piece of state, like I do here, this random number setter, it sets this random number. When I click this button down here, it sets this different piece of state, which triggers a re-render. This function within my useEffect hook, it's going to run again, or it calls this function. Okay, so the first argument is a function to the useEffect hook that you can pass. And by default, React is going to call that function that you pass to the useEffect hook on every single render. So you can see when I click random number setter, it's not even related to my code within my useEffect. I console log the count. I don't care about the random number, but you can see this like number 6 here is going to keep going up. 7, 8, 9, 10, so on and so forth. That's probably not what we want. So how can you kind of control that? Well, the second argument to the useEffect hook is, so I'm going to do comma. This comma is after my function here that I passed into the useEffect hook. I'm going to do comma, and then you could pass what's called a dependency array. So it's basically saying like, okay, for your function that you pass in as your first argument, what dependencies does that function have? Or what pieces of state does that function depend on? Well, in our case, we only care about the count. We use our count right here. So what's the dependency here? Well, it's going to be the count. So you can put that in your dependency array. And now what React is going to do is it is going to run this useEffect hook, or the function, as the first argument in these useEffect hook. It's going to run that function. And you could also pass a named function here as well. I'm just inlining an anonymous function, which is probably how you're going to see this written the most. But it's going to run this function when this component mounts, so the initial render, or anytime the count changes. So if count goes to 1, goes from 1 to 2, 2 to 3, it's going to console log our count again, and it's going to run this first function again. However, since we don't put our random number piece of state in our dependency array, which we shouldn't because our function doesn't depend on that, or doesn't care about that at all, when we set the random number and it re-renders, it's not going to rerun this function, which is probably what you want to do. So normally you do want to pass a dependency array. And what you're going to see is when I increment it, you can see that it console logs the current count. But then when I hit this random number, it's not console logging the count, because it's only going to trigger the recalling of my passed in function to useEffect when one of the values in the dependency array changes. Now you could pass multiple values here, and that's totally fine to do as well. But just make sure that, you shouldn't choose the dependencies. They should be things that your function actually depends on. So what I mean by that is like, I wouldn't want to set this up to where I'm rerunning this function when random number changes, because my function that I passed to useEffect here, it doesn't care about random number. It doesn't use it in any way. There's kind of nothing it does here that cares about it. So make sure that your dependency array, or the values in your dependency array, actually match what your function that you pass into useEffect depends on. Now you can use multiple useEffects in a single component. Something like this is totally fine, and all of them can have different dependency arrays, and that's perfectly okay to do. But like I said earlier, really you probably shouldn't have that. Maybe there's cases to where it makes sense, but for the most part, I like components that do not have useEffects in them. It makes it much easier to reason about. One other thing that you can do here with the useEffect hook is you can return a function from your passed in function that will run when this component unmounts. So for our useEffect demo here, if I go to a different page and we unmount our page component right here, that function is going to run. So in our passed in function, if we have a return statement and we return a function, and then we do something in this function that we return, React is going to call this return function here when this component unmounts. So if we left this useEffect demo page, React would call this return function from our passed in function, which is our first argument to our useEffect hook. A little complicated, but just know if you need to do something when your component unmounts, you go to a different page, return a function from your function that you pass in to useEffect. Now, when might you actually do this? Well, I know in my professional application, we do something like at the top of the useEffect, we might call a connect function to connect to a certain WebSocket. And then when we unmount, we'll call a disconnect function and do something like that. So connect to the WebSocket on mount. When you leave the page, we don't need to keep that connection going. We need to kind of clean that up. So we're going to return a function that is going to disconnect from that WebSocket connection. Now, let me show you one other example here. So, in your passed in function, you might have various logics. So like if count is greater than 10, then maybe here you could set your count back to 0 to reset it. And this will work, but there's a but to this. So let's first see that it works. All right, I'm going to increment this. I hit 10, and now it goes back to 0. So it's basically in this like infinite loop here. Now, what's the problem with this? Well, what are we doing here with our useEffect hook? We're actually responding to a user action, which is not what you want to do in a useEffect hook. Because we wouldn't need to use this hook whatsoever here. Let me get this random number out of our dependency array. We wouldn't need to use this useEffect at all. We could just do this when we set our count, when we increment it. We could check, okay, if this prev count is greater than 10, set it to 0. So let's go ahead and do this. I'm gonna adjust this a little bit. By default, return prev count plus 1, but we can do if prev count is equal to 10, then we are going to return 0. And then we wouldn't even need this useEffect hook whatsoever, which is my favorite. So if you do this, we can see that we get the same effect here. We get to 10 and it goes back to 0. And this is much better practice than trying to use a useEffect hook for this to track some state and then set that state when that state is meeting a certain condition. Because like I said at the intro, this is user actions triggering the changes of this code. We don't need to use useEffect or effects for that type of action. useEffect, like I said, is going to be something like connecting to a WebSocket. Like I think the perfect example of useEffect is, okay, when our component mounts, and if you pass an empty dependency array, that is going to mean that you are only going to run this passed-in function to useEffect when your component initially mounts. When this component initially mounts, we're going to call a connect function and connect to a WebSocket. Maybe we pass in a certain channel name there. And then what we can return is we just want to disconnect from our WebSocket. So when it mounts, it connects it. When it unmounts, we return a function from the passed in useEffect, and it's going to disconnect. Now you might have other stuff like, on mount, you need to sync your app with an external API, like a logging service or something like that. That's another great example where you might use these. But just know, like, if you're ever like responding to user actions in a useEffect, you can probably restructure your code and do some better stuff. The TLDR here on the useEffect hook is it's a function that you import from React. 2 arguments are possible. One is mandatory, and the first one is going to be a function that is by default going to run on every single render. You can also return a function from that passed-in function if you want to run some code when your component unmounts. But if not, you don't need to return any function from your passed-in function to useEffect. And then the second argument is going to be a dependency array. It's basically going to be like, all right, for your passed-in function, what does it depend on? Are there any like state variables that it uses, or what does it kind of need to stay in sync with? You're going to pass those to your dependency array. Your passed-in function, it's going to run on mount, as well as anytime one of these passed-in values of your dependency array, anytime these values change. And for the most part, you're going to want to pass a dependency array to your useEffect hooks. So hopefully this is clear. Hopefully I didn't drag on too long here. It is kind of a trickier hook, but like I said, it shouldn't be something that you use a ton. Understanding refs in React.js. So this video, we're going to kind of do a quick overview of what refs are, using refs versus just using state, when you should use refs in your React applications, a couple of best practices, and then we'll kind of get into some of the technical details of how they work, as well as an example here. So what are refs? Well, I like to think about them as more of a last resort to hold on to values that aren't used for rendering. So you won't need them often, but when you do, they can be a kind of a useful escape hatch to maintain mutable values across renders. On the refs side of things, you're going to call the useRef hook with an initial value, and then that is going to return an object that has a current property with your initial value. So a ref, you call the useRef hook just like you would with the useState hook, and you call it with an initial value But instead of just returning that value as well as a setter function like useState does, it's going to return an object that has a current property, and that current property is going to contain your value of that ref. Whereas useState, as we've covered in previous videos, accepts an initial value, but then it returns an array where you have your current value and a setter function. So value, set value. But a ref just returns an object with a current property that points to the ref's value. Now, one of the biggest differences between a ref and state is that a ref does not trigger re-renders when you mutate your ref. So if I use, myref.current is equal to some new value, it doesn't trigger a re-render of your page. Whereas state, when you call the setState function, it does trigger a re-render of your page, which is a key difference there. And it can get you in trouble if you don't really understand that about refs and you try to use them. This is also why it's important to not use refs for rendering or to read values during rendering. And we actually kind of say that right here. Avoid reading or writing during rendering. And that is because if you try to read a value during rendering, well, if you change the value of that ref, it's not going to be re-rendered, which means that if you try to read that value during rendering, that value is not going to be updated to the page like it would with state. Because state you can read at any time here. But refs, if you try to read a value during rendering and you try to present that to the page, it's probably not going to get updated like you think. Now refs, they are mutable, so you can modify and update the current property, this property here, of your ref. Whereas with state, these should be treated as immutable, where you use the setter function to modify the state value without mutating the piece of state. What are some situations where you would actually use refs? Well, if you're storing timeout IDs, that would be a good use case for using a ref, because it's a value that you're probably not going to use within your page, your rendering page, but it is a value you want to maintain across re-renders. So that would be a good option for refs. Storing and manipulating DOM elements. I'll cover this in my next video, but this one is a very common use case of refs that you'll see. Storing other objects that are not used for rendering. So again, if you're not going to be using that object to show the user something, well, this is where you might use refs. And then choose refs if the value doesn't impact rendering logic, but needs to persist across renders. So very similar to what we've kind of covered already. Now, a couple of best practices: avoid overusing refs for core logic or data flow. This just kind of comes back to refs are more so like a last resort, and they shouldn't be used as like a default behavior that you try to do. And they should not be used for like your main logic, nor should they be used for data flow. It's just maintaining values across renders, but values that you're not going to use for rendering, and it's not really used for kind of core logic or the data throughout your application. Avoid reading or writing ref.current during rendering. We discussed this already. If necessary, use state for predictive behavior. A little bit more on how refs work. You import the useRef hook from React, and then you can pass it in initial value, just like you would with state. It's going to return an object. So we're saying const myref is equal to useRef. So it's going to return an object to myref, and then myref is going to have a .current property that is going to contain your initial value. So if our initial value is 0, and then we use myref.current plus equals 1, it's going to set that .current property to 1. But let's look at this a little bit more with an actual example in code. So if we go to VS Code here, this is a running application that I created. If we come to VS Code, you're going to see we have this refs page, and I set up a counter using state and a counter using refs to just kind of show you how you don't want to rely on refs for rendering logic. We have our state counter, which is just counter and set counter is equal to useState. And then here we have our counter ref is equal to useRef, and we set it to 0. And when we increment our counter ref, we have to go counterref.current. We access the current property on our return value of useRef here. counterref.current plus equals 1. And then for our increment counter state, we say set counter is counter plus 1, but we should actually, to do things the right way here, we should pass in a function here, and I should say prev count, and then we should set it to prev count plus 1. As when you're setting state based off of the previous state value, this is just a better practice here to pass in a function, so you're always guaranteed that previous value here. So our set counter, we call that here, and then we also have our ref counter. And if I scroll to the bottom, you're going to see that in our example here, we have our counter ref. We just access the counterref.current to show the count for our ref counter. And then for our state counter, we just show the counter state value. Clicking on the state counter, we see it works exactly how we would expect. But if we click on the ref counter, then I am clicking on this right now, you see that it's not incrementing the count. And the reason for this is because when we click this button and we call this increment counterref function and we set the counterref.current plus equals 1, this does not cause a re-render. So a React page doesn't re-render when this state is mutated, which means that this counterref.current is also not going to change, which is also why I kind of harped on it in this video. You don't want to use refs for rendering purposes here. So rendering out this to the page, you don't really want to use ref data to do that. Because if I come back and now if I click increment state counter, it is going to re-render and we should see this count over here update. So I click on it and you see my ref counter is now updated to 6 because I clicked on this 6 times before, which it did increase my ref value, but it didn't re-render until I actually caused this state change right here. So let's do it again. And then I'm going to trigger a re-render by using my state update. And we see it gets updated to 11. So hopefully that makes it clear why you don't want to use a ref for rendering logic like what we're doing here. We're trying to use that value within our actual JSX rendering. That's kind of a no-no here. And you would just want to use regular state so you can have reactive state updates like we do with our state counter here. So just to kind of recap here, refs are somewhat an escape hatch or last resort to hold on to values that aren't used for rendering. You won't need them often, but when you do, they can be quite helpful to maintain mutable values across renders. For refs, they work a little bit differently than state, to where you still call the useRef hook from React with an initial value, but it returns an object with a current property that represents the current value of your ref. It doesn't trigger re-renders when you change it. It is mutable, so you can modify the current property, just like what we do here in our example where we modify counterref.current. We mutate that directly here. That's okay to do with refs, but you should avoid reading or writing during rendering. So as I showed in the example down here, this is not going to work out very well using this during the rendering. It's just not going to get updated as you might expect. You should probably use refs if you're like storing timeout IDs, you're storing or manipulating DOM elements, storing other objects that are not used for rendering, or you need a value that doesn't impact rendering logic but needs to persist across multiple renders. Now you should avoid overusing refs, especially for core logic and data flow. And then, of course, like I talked about, avoid reading or writing the ref.current during the rendering process. So hopefully that gives you a good idea of refs. In my next video, I'll do an example of using refs with elements, as that tends to be a very common pattern for refs. But hopefully this gives you a really good idea of how they work, when you should actually use them, and how they differ from using state. So how can you use refs in React.js to gain access to DOM nodes or HTML elements? Well, that's what we're going to cover in this video. And then towards the end of this video, we're going to cover a kind of word of caution when it comes to using refs in React. But the example that we're going to use here today is we have this section element. I've gained access to this element using refs, and then we're going to call that element dot scroll into view when we click on this button here. So as you can see, I click this button and it scrolls this element into view. Now, this is just one example of using refs to gain access to an element. There's several different things that you might use this for, but this just kind of goes to show how you might use refs with your DOM elements. So let's actually look at the code for this. It is pretty straightforward here. In my previous video, I go over kind of an overview of how to use refs and an example of doing so and additional kind of words of caution with using refs. But here, what we do is we just call the useRef hook. We add our type annotation here because I am using TypeScript here. And then we give it an initial value of null. That's going to return into sectionRef here an object with a current property. Now, the kind of key here to using this on HTML elements is that for your element, you can add an attribute that is called ref. And then you can set your variable containing your ref to that element. So here on the section that we want to scroll into view, I just say ref is equal to section ref, which matches my section ref constant here. That is the return value of calling the useRef hook. So useRef returns an object with a current property, and then we set for our section element, ref is equal to section ref. But if we wanted to kind of track this P element, this DOM node, we could totally do that as well. And we would just say ref is equal to, instead of section ref, we might say para ref for paragraph ref or something like that. So you can set a ref attribute on your different elements. And that is basically going to mean that your current property is now going to represent this section DOM node here. So we can see I'm console logging my section ref right here at the top of the page. So if we come back and I open my console, we can see I'm console logging it here. It's an object with a current property, and you can see it is an HTML element. It is a section.h96 background gray 700. And you can see when I hover over it, my inspector highlights it here on the page because this ref is representing this HTML element, which means we have access to all this HTML element's properties and values and methods that we can use. So you can see it has the inner text. You have reached the target section. You have reached the target section. So this just gives us access to this direct HTML element. So then quite simply, when I want to click on this button that says scroll to section, we pass in handle scroll. And then all I do here is I do a quick check to make sure that the section ref.current exists and it is an element. But then we just do section ref.current. So this represents the HTML element here. And then HTML elements will have a scroll into view method. And then we call that method, and then we just pass a behavior of smooth to kind of customize how it scrolls there. And that is exactly how we get this effect right here. So pretty straightforward when it comes to using refs with elements within your application. You just use the useRef hook like you normally would. And then for whatever element that you want to use or that you want to track, all you're going to do is use a ref attribute on that element and then set that equal to your ref variable returned from the useRef hook. And then that will give you access to that element. Now, of course, you could use this for different things, but let's kind of go over that word of caution that I mentioned earlier. And that is avoid changing DOM nodes managed by React. Modify adding children to or removing children from elements that are managed by React can lead to inconsistent visual results or crashes. And they showed an example here as well. I'll link this if you want to read kind of more about this, but it does say that it doesn't mean you can't do it at all. It just requires caution. You can safely modify parts of the DOM that React has no reason to update. For example, if some div is always empty in JSX, React won't have a reason to touch its children list. Therefore, it is safe to manually add or remove elements here. So basically what it's saying here is that, like in our example, that's fine to do because we aren't modifying the DOM manually with refs. All we are doing is using the method on the ref to scroll into view. So we're not like adding DOM nodes to the page. But what you need to be careful about is modifying the DOM manually using refs, especially if React might modify similar parts of the DOM. It can result in like it says here, inconsistent visual results or crashes. So before manually updating the DOM with refs, I would definitely read through this section of the docs and just make sure that you're being careful about it and kind of doing it correctly and not potentially introducing bugs with using refs in manual DOM manipulations. So to end here, let's actually just kind of go through this recap that they have in their docs. So refs are a generic concept, but you'll most likely use them to hold DOM elements, just like we did in our example. You instruct React to put a DOM node into myref.current by passing a ref attribute to a certain element, just like what I showed you with my section element. Usually you will use refs for non-destructive actions like focusing, scrolling, or measuring DOM elements. Like what we did, we used scrolling as an example. And then finally here, it also covers kind of what we covered earlier, avoid changing DOM nodes directly with refs that are already managed by React. And it says that if you do modify them, modify parts that React has no reason to update. So that is using refs with elements in React.js. Let me know if you have any questions below, but hopefully that makes things clear. You know, this probably shouldn't be your go-to solution for everything, but in a large application, I think you will find yourself needing to use refs at some point for certain functionality. So I hope you enjoyed this video. I hope you learned how to use refs with elements, and I will see you in that next one. I'm going to show you how to use the useCallback hook in React to prevent a common performance issue that you may run into in your React applications. So what we're going to do here is let's look at the code here. And basically you're going to see I have this useCallback demo function. It has a piece of state here, count and set count. It has a function called handle click, which basically just sets the count to the current count plus 1. And then we pass that handle click to a button component down below. Now our button component above, it accepts the on click. And when you click on it, it's basically going to increment the count. Now I also have this button wrapped with React.memo. That's so it prevents unnecessary re-renders when the parent component re-renders. If you don't know how that works, make sure to check out my very last video I did on React.js. But effectively, it's going to make sure that our button component is only going to re-render when its props or state change, which kind of takes me right into the issue. We still have an issue here to where for our handle click here, we're just initializing this function every time the useCallback demo function re-renders, which means that every time useCallback demo re-renders, we are going to create a new instance of this handle click function and then pass it as a prop to our button. So every time it re-renders, we are then going to also re-render our button because the prop is changing here. We are technically passing a new reference to a function every single time our useCallback function re-renders, which means that if we come back here and I click increment, you see I console log button rendered. And you see it double console log because I'm in development mode here. But we have this button rendered console.log. So every time I click on the button, even though this function is technically staying the same, since we are reinitializing a new function here every time useCallback demo re-renders, we're actually passing a new reference to a function here for the on click, and that's going to re-render our button component every time we click on this, which in most cases is actually fine, and it's not a performance issue. But you could imagine a world where maybe our button component is an actual pretty complex component, and maybe it makes network requests, or maybe it has some more expensive computations, and maybe it just doesn't render all that fast. Well, in those cases, if you're passing a function as a prop, you have to be really careful about, are you passing a new function every time the parent component re-renders? And is that going to cause issues in your application? So the way that we can fix this, and the way that we can prevent passing a new reference to this handle click function on every re-render, is by using the useCallback hook. So we're going to get rid of just this inline function that we are going to reinitialize every time we re-render the useCallback demo component. And then we are going to use the useCallback hook. So now I'm saying const handle click is equal to calling the useCallback hook that we import from React here. So import useCallback from React. And then for this useCallback hook, we pass a function, and this function will set the count to the previous count plus 1. And then basically we need to tell the useCallback hook as a second argument to it, when do we want it to reinitialize this handle click function? Well, for us, we want the function to always just set the count to the previous count plus 1. So we don't particularly care about anything other than just making sure that we don't reinitialize the handle click function. So we just pass an empty array. If our handle click function had dependencies and we wanted to actually reinitialize the function when some other variable changes, then we would put it in this dependency array right here. But this way, we're only going to initialize this handle click function once, pass it to this button. So now our button, it's wrapped in the React.memo, so it's not just going to re-render when the parent re-renders. And then also the prop of onClick, it's going to maintain the same function reference. So it's not going to recognize that the props are changing. So by just clicking the increment button, we shouldn't be re-rendering this button component here. So if I clear my console and I refresh for good measure here, and I click increment on the button, you see that we no longer get any console.logs. And that's because, like I said, we're no longer passing a new instance of the onClick function every single time into the button. We're passing it the return value of our useCallback hook, which is basically saying, I want you to make sure this function stays stable. I don't want you to recreate this function every time the useCallback demo component re-renders. And then that prevents this onClick prop from changing, and it prevents us from re-rendering this button component. So in summary here, anytime you're passing a function as a prop, you might have to think about, okay, do I care if this component that has that function as a prop, do I care if that component re-renders when the parent component re-renders? If you don't, then great, just pass it as we did initially. But if you want to make sure that you really prevent unnecessary re-renders in that component, and maybe it's a more computationally expensive component, then it's a good idea to make sure for that function that you're passing in as a prop to just pass in the return value of the useCallback hook. And then the first argument of that useCallback hook is going to be a function in which you do the logic that you originally wanted to do. And then the second argument is going to be a dependency array, basically telling React when you want to reinitialize the returned function. And then this way, that prop is going to remain stable, and it's really only going to re-render the component that you are passing it to when you actually want it to, not just when the parent component re-renders. And likely, you might have to use this in combination with React.memo, because without React.memo, this button component is still just going to re-render by default when its parent component re-renders.